All right, this tutorial is on the Big Ideas Geometry section 8.3, Proving Triangle Similarity by SSS and SAS. And those two things, similar to when we talked about congruency theorems, are side-side-side similarity theorem, side-angle-side, and being able to prove slope criteria using similar triangles. So side-side-side is different than the congruency version, because all of your sides that are corresponding to each other needs to be proportional in order for your two triangles to be similar. When we talked about congruency, all of the sides needed to be equal. So since this is a similarity version of that, they just need to be proportional. Or when you set up a fraction of the corresponding sides, they are reduced down to the same ratio. So in either DEF or GHG, similar to our first triangle ABC. So these numbers are color coordinated to help you identify which sides are corresponding to each other so that you could set them up into a correct proportion. So let's compare first ABC and DEF by finding the ratios of those corresponding sides. So when we're using our side-side-side similarity theorem, it's easiest to start with your shortest sides first, because if they're going to end up being proportional, your shortest sides are going to have the same ratio, then your longest sides are going to have the same ratio, and the middle sides are going to have the same ratio. So the reds are the shortest, blue are the longest, and then the green is your middle. So we're going to first compare AB and DE, which is 8/6. And that gets reduced down to 4/3. When you compare the blue, or the longer sides, that's going to be 16/12, reduced down to 4/3. So far they're the same, so far we're good. Then our greens, BC/EF, is 12/9. Those are also going to be 4/3. So because all three ratios are equal, we can conclude that triangle ABC and DEF are similar. So now let's check GHG to see if that one is similar to ABC. We're going to do the exact same thing, short sides, long sides, and in the middle. So our shorts are going to be 8/8, which is 1. Our longs are going to be 16/16, which is 1. And then our remaining 12/10, which is 6/5. So even though we have two sides that are proportional with the same ratio, we don't have all three sides. So we cannot conclude by side-side-side similarity theorem if ABC and GHG are similar. They are not similar. So now we could use this similarity theorem to solve for a missing value inside our triangle. So we're going to try and find a value that makes our ABC similar to DEF, where the X is on our BC side length. So we need to write a proportion that is going to use BC in one of our ratios, or find the ratio without using the X and then plug it in after the fact. So I'm going to use the one that includes BC, because that's just going to allow us to then cross multiply and solve from there. So substituting in our values, AB is equal to 4, DE is equal to 12, BC is our X minus 1 side length, and EF is 18. From there, you can just cross multiply 4 times 18 and then 12 times the parentheses of X minus 1. Go ahead and simplify this down using your algebra rules. Multiply, add 12 to both sides, and then divide by 12 to get X equals 7. So if X were to equal 7, that value would make triangle ABC similar to DEF, because they would have the same ratio set up in a proportion. So you could check this by plugging it in. 7 minus 1 is equal to 6. And then you can plug that back into your original proportion of 4/12 equals 6/18, reducing both of those to make sure that they are the same. Now you can do this with the DF as well. Substituting that in, 3 times 7 plus 1 is going to be 24. So you get 4 over 12 equals 8 over 24, and those two ratios are going to be the same. Okay, so the second theorem that we're going to talk about today is side angle side similarity. So side angle side says that if one angle of a triangle is congruent to a second angle of a second triangle, and the lengths of the sides, including these angles, are proportional, then they're similar. So this is, again, the same type of setup with SAS for congruency, but this time our sides are going to be proportional. So please keep in mind that the sides must be included. Your sides must be touching the angle that you are saying is going to be congruent. So in this diagram, X and M are the angles that we are saying are congruent. So XZ and XY are the two sides that touch that angle. So that's why they are these sides here in blue. Then MP and MN are the sides that touch the red angle M. So that's why these are the sides listed here in that theorem. So let's say that you are building a lean-to shelter starting from a tree branch as shown in the picture. Can you construct the right end of this so that it is similar to the left using the angle measure of the lengths shown? So we are trying to determine, using that both A and F are equal because they are both congruent to 53 degrees, what is going to be the length of this right end so that it's similar to the left. So we need to compare the ratios of the two sides, of the two short sides first. Remember, we're comparing the shorts together and then the longs together. So we have 9 over 6. The 9 feet is the AB and the 6 feet is the FG. Reducing this down to 3 over 2. Then we're going to do the longer sides. AC is equal to 15 and FH equals to 10, reducing those equal to 3 over 2, and the included angle between them is 53 degrees. So since your angle is congruent and the included sides are proportional by SAS, you can say that these two triangles are similar. So yes, you can make the right end similar to the left end of this shelter.